And yeah, that looked alright. Welcome back everybody to yet another episode. In this one, we're gonna continue from where we left off in the previous episode and add some more advanced version of Pathfinding. It's still pretty basic, but now the enemy is gonna be able to turn in case he cannot continue walking in the current path. So, let's get into the episode. Before we continue working on our enemy, we need to add the animation from editing to our playing as well. And since they will be used in both of these classes, we can actually add it to our game scene, which is the superclass for all of them. So we can take our update tick method and move it into our game scene. Instead of public, we're going to use protected. So only child classes from this class can use it. And we will also add a protected int. What did we have? Animation index. Protected int animation speed equals 25. And also a protected int tick. I think that's good. Yeah, that's all we need. Now we can remove that from our editing, because they are now in our game scene. We still call update tick, but actually let's add an update method. This way we have update tick where it should be and not in render. So in update tick inside our update method, and then we go to game, and inside here for our edit we say editing.update. All right, now that's gonna work. And we can go to playing, and in our update, and we start by updating tick. And then in our draw level, we have a check just like this one. We can actually copy it and paste it. And this is animation. We can actually move that one too to our game scene, since both of them is going to use it. And we're going to turn it to protected as well. And we might as well move these two as well, because they are being used both in playing and in our editing class. And then we protected. Save that one. Check for errors, no errors. Is animation is also here. From playing, save, we can remove this one. So if we run the game now, in playing we should have animation. And we do have animation. Great. So now we can get back to our enemy classes. And we're gonna make a very simple yet working pathfinding for our enemy. So the enemy is gonna check his current position plus the direction, which is the speed. If that tile is that tile a road, then we can move there. If it's not a road, then we need to figure out some other direction. So we got a little bit of work to do before we can actually try it. We're gonna add some constant values, a new class with constant values. And yeah, let's get started, shall we? Let's start out in our enemy class, and here we will add a new variable called private int last there for last direction. And we will need a getter, a getter for this. Turn last there. We will also need to remake our move method here, but before we do that, let's go to our help package, new class. And we're gonna call this one constant. In here we will have several smaller classes. This one will be a static class called direction. And in this new static class direction, we will have left, up, down, and right. So public static final int left equals 0, and we will have a value for each of the direction. Up equals 1. And we are adding them in a clockwise direction. So public static final int right equals 2, and public static final int down. And the use case for this will be much more apparent when we start using it, so let's just get into using them right away. And in here, let's give last there a value right away. So last there equals right. And it's not gonna know what that is because we need to import static helps constants, and we take all of them, not like so. We actually need a very class, and the class was called direction, like so. And now the last direction is right, and that's good for now in our enemy class. Then we can go to our EnemyManager and we'll start doing some work here as well. And inside our update method here in EnemyManager, we can actually remove this move for now and add some brackets for this array. And in here we need some type of check for our enemy if is next tile road given the enemy position and also enemy direction. So we're checking the next step. Would that be a road or not? If it's a road, then we can move normally. So we can say something like if is next tile road, and we will pass in an enemy. If that's the case, then we move enemy like we did before. So we need to make a new method, public boolean, and it will take in a enemy e, and we need to return like so, and we need some sort of return. Just return false for now while we are working on it. And we're gonna need enemy pos, enemy direction, and we also need a tile at new possible position. So we're checking what tile it is in the next step. And we're gonna need a variable called int new x equals e.get x. And we also need to get the speed. And we can just add a simple method here to get it, which is get speed x. And we pass in e.get last direction. And we do the same for int new y equals e.get x, get y plus get speed y e.get last direction. And only one of them will return a value depending on what direction we are heading. Let's begin working in speed x. So here we say do a simple check if, not last there, we're actually going to call it there because last there doesn't make any sense. All right, if there is equal to left, and we need to add that. We need to import it. Well, import static helps constants direction dot star. We get all of directions. If the direction is left, then we return the speed 0.5 float, but negative because left is negative on the x-axis, so we need to return negative 0.5. But instead of writing negative 0.5 there, we can actually make a private float speed equals 0.5 float. And down here we, instead of saying 0.5, we say speed and return it. And if it's not left, else if there equals right, we return speed. But if that's also not true, then we return 0. So the function here goes the current position plus 0, because it's going up or down, not left or right. So the added value will be 0. And we're going to do the same for y here. There we do copy, paste, but up and down. Because down is increasing in y, up is decreasing in y. And if none of those are true, that means it's left or right, so we return 0. But up here we need to cast this into integers, because we're gonna need whole numbers when we're checking the tile, not floats. So like that, save it. Now we have, oops, what is that? That doesn't look right. That looks right. That looks right. All right. So now we have a new position that we need to check, but we have no way of checking if the tile is a road. So let's go back to our constant class here, and let's make a new class called public static class tiles. Just like up here, we're gonna make 3 new variables. One is called public static final int. Actually gonna copy that. This will be called a water equals 0, grass equals 1, and road equals 2. And now we can do the same thing with tiles that we do for directions, but we need to go to our tile manager, and in here we can actually start to replace the name of the tiles with the type of tiles instead, because we're not going to use these names anyway, so we might as well remove them. But we're not going to remove them here first. We're going to remove them in our tile class. So we can remove string name and also from the constructor and from that one as well. Then we can save and we can remove that one down there. But instead of the name, we go int tile type. And we're gonna add that one to our second here as well. This dot tile type equals tile type. Copy and oops. And paste, and up here we add the tile type. Save it, and then we do a simple getter for it. Int get tile type. Return tile type. Like so. But now we need to add tile types to all of our tiles. And we actually just have 3 types of tiles. We have water tiles, this one and all of these. We have road tiles, which is all of these. Then we have 1 single grass tile. But before we get started, let's just add the import we need for tiles. So import static helps constant tiles and all of them. And now we can actually remove the string and add grass for our grass tile. For our water, we add water. And for all our roads, we add road. But I just realized that we have some double naming going on here. Our grass tile right here, this one is called the same as grass, and that's not great. So we need another way of doing this. And I think the easiest one is simply to go to our constants, and instead of saying water, water tile, grass tile, road tile. And this way we don't make any confusion, so we say grass tile instead of grass. Water tile. And for a road, we need to go road tile. And that shouldn't give us any more errors. Good. So now all of them have been added, and what we can do now is to go back to our EnemyManager, and in here we can add a if get tile at the position new x new y is equal to road tile, and we need to add that constant to constant dot tiles dot star. And if that's the case, keep moving in the same direction. Simple as that. And we're gonna make a else find new direction. But actually, let's name this not get tile type, which I think is a more correct name, yeah. So public, not public, private int, because it will be an integer returning. We have get current type int x, int y. So we say playing dot get tile type xy, and we need to return it. Return. But we need to create this in plain as well, and we can do it above all the mouse events. So public int x, int y. And we need to check what tile type they are, but in this class right here at Tile Manager, we don't have any get tile type, but we can actually just use a normal get tile int ID and then use that ID to get the tiles type. It's gonna make more sense when we add them all, when we write it all out. So game.getTileManager.getTile. Now we need to pass in an ID, and we have an ID somewhere in this array. We can use the level array. Actually, let's make it easier to read. So int ID equals level y divided by 32 and x divided by 32. Now we have an ID because we're in this array. So we can pass in the ID and get tile type. And of course we need to return it, because we have a position and we pass that position in here, but we divide it by 32 to get the coordinates, and then we have an ID, and with this ID we call tiles.getID, which gives us a tile. So we have the tile, and now we can get the tile type for that tile. So now let's go back to our EnemyManager class, and in here let's just pretend that we get a true. So we get a true, then we call enemy, because we still have an enemy object here, enemy.move. And we say, actually, we don't say anything yet. We go in here and we're gonna change up this move method. Instead of a x and y, we're gonna ask for a float x, not float x, float speed, and int direction. And in here, we make a switch there. And depending on case left, and we already have that, yeah, right. Make a break, and we make a copies, left, right, there we go, left, up, right, down. And we don't need any default because we're not returning anything. But if it's the left, then we say this.x plus equals speed. No, not plus, actually minus. If it's up, then we say this.y minus equals speed. If it's right, this.x plus equals speed. And down, this.y plus equals speed. So instead of giving it a 0 for x and speed for y if you're going up or down, we simply give it the speed and the direction it needs to go. And now in our EnemyManager, we simply remove these two and we place the speed and then the direction. But we didn't change the direction, so we simply go e.get last there. And like so. So now we will move in the same direction because the next tile is also a road. And we did a lot of coding, so let's just hope everything works by running the game. It started, that's a plus sign, so let's try it. The enemy is moving, I think it's working, and he's gonna stop at this road here, but actually, now when I think about it, he's gonna move to this grass tile right here. And then it's going to stop. And the reason for that is that we're checking the position, which is the top left corner of the enemy. We're not checking in the center or anywhere, so we need to take into account for the width and height of the enemy. And let's do that now. And to make sure we don't walk into any grass like we just did now, we need to take into account the height and the width of the enemy. And if we're walking left or up, we don't need to care about that because the coordinates are already good as they are. But if we're walking to the right, we need to take into account for the width of the enemy. And if we're walking down, we need to take into account for the height. So let's add that into our check here. I'm gonna do that by changing the name for our speed here. We're gonna call it get speed and width. And for y we do get speed and height. And let's just call them by the correct name. And we can start in the get speed and width. If it's left, then we don't do anything. If it is, then we say plus 32. And for down, we say plus 32. And we probably should have a variable for this, but we're never going to change the size of the tiles or enemies or anything, so 32 is good enough. And let's just check if that solved our problem. And he did. So that check is now working. Perfect. What we need to do now is that when he hits a corner or a stop or whatever, he needs to figure out a new direction. So that's the next task, so let's get into that. We're actually going to add one more part for this check, which is if, else, and we need some parentheses like that. If else is at end enemy. What we're doing here is just simply checking if the enemy has reached the end, and if he reached the end, then we do something like minus HP or that kind of stuff that you normally do in a tower defense game. But we're gonna leave this blank for a couple of episodes, but we need to check anyways. But we can make a comment here such as reached the end. And let's just add that method. We're just gonna return false for now. We're not gonna mess with this just yet. It's not if else, it's else if. That's the way it should be. Alright, so in here, we couldn't keep moving the normal direction, and we're not at the end, so we will set new direction and move. Let's just move as well. There's no reason why we should come back here. Anyway, and create the method. And the code in here will not be too difficult or complicated. We simply need a direction, e.get last direction. We need his current direction. And if the direction is equal to left or direction is equal to right, meaning he's going left or right, then we're going to check up and down, because we don't want him to walk straight to the right, because we don't want him to walk right and then he cannot turn and he goes back. We don't want him to go back where he came from. So if he's walking left or right, then the only two options is up and down. And the same for if you're walking up or down, then only two options is left or right. So we're just gonna keep it like so. And in here we will add a int new y equals, like we have up here actually. I think we can copy this. But instead of saying the current direction, we're gonna check up. So it goes in here, checks for up, and returns the up. Yeah, that's good. And if get tile type, e.get x, and we need to cast that into an integer, new y. If that's equal to road, then we can move there. And it's not road, it's road tile. Like so. And we can remove the brackets. And if we could move up, we simply say e.move speed and up. Simple as that. But if we cannot move up, then we go e.move speed down. But if it's not left or right, it's down or up. And for up and down, we simply do the opposite. So we take new x, but instead of the current direction, we pass in right. If get tile type, new x, and we need to cast e.get y. If that's equal to row tile, then we can move to the right by e.move speed right. Otherwise, we simply e.move left speed. Like so. I think this is gonna work, but there's one crucial part we need to actually add before we run, otherwise it will go in an endless loop, and that's when we do a move, we simply say last direction equals there. So if we change the direction, we also change the last direction here. So next time we are in a new direction. So let's try and see if it works. So he should come to this corner and then walk up. Because he's walking left or right, he's walking right, so he's trying up first, which should be true. He should be walking up here. No, he did not. Why is that? To know what is going wrong here, we need to zoom in a bit. First, our enemy moves to the right, no issues. Then, eventually, he will move into a stop. He tries to go right, but he can't. There's a grass tile in the next step. So, he checks the tile above, which he should, but here's the issue. He never fully moved into the corner tile, so he is still in the tile to the left with the top left corner of the hitbox. So he's checking the tile above that point, which is grass, so it returns false. So he picks the direction down. But the next frame he tries to go down, but can't. There's a grass tile there. So he checks for a tile to the right, but there's a grass tile there too. Therefore he selects the direction left. And now we understand why the enemy is moving like this. And to solve it, all we have to do is to take this offset into account before we check. And I think the easiest way to solve this would be to place the enemy in the correct spot and then we check for a new direction. That way we get rid of the offset and we can check the correct tiles that we actually want to check. Let's just add that functionality in the set new direction and move. First we get the enemy's current direction and then we say move into the current tile to 100%. I think the easiest way to do it is to get the coordinates in the level array and then just +1 depending on what direction you get. So let's get the coordinates, which is int x coord equals e.get x divided by 32. And this needs to be recast into a integer, and then int e coord equals the same divided by 32. And let's just add a method. What should we name it? Fix enemy offset tile, something like that. And we place enemy there x coord e coord. I think is good enough. And in this method we can add a switch for dir case left break copy left up right down. And if the enemy is moving to the left, we remove one. But there could be a slight possibility, which I think is going to happen at some point, that the current coordinate is 0 and then we remove one and then we try to apply that to the level array, then we get an error. So we just check here if x coord is more than 0, then we go x coord minus minus. This just makes sure the coordinates are at least 1. If it's 0, then we don't remove anything. And for up, we do the same check. If y coord is above 0, then we can remove something. And for right, we need to do a check as well, but instead of 0, we need the max, which would be 19, because it's 20 by 20, but it's index, so it would be 19. So if x coord is less than 19, Then we can go x chord plus plus. And the same check for down if e chord is less than 19, then e chord plus plus. And after this switch, we need to tell the enemy to move into that position, which we do by e.setPosition, I think, because move is not going to work, but we need a new enemy method that we can call public void set pos, and it needs to take in a integer x, integer y, this dot x equals x, this dot y equals y. And let's just add a comment here so we know why we have it or why we shouldn't use it all the time. We can say don't use this one for move. This is for position fix. Whatever. That's enough. We will know what it means when we read this later. Then we can come back here and e.setPosition x chord times 32, y chord times 32. And I think this is going to be good enough, because we only come in here if he fails to move in the current direction. And no matter if we want to go left, right, or up and down, he's going to fix this first of all. So let's run it and see if let's see if that did anything. All right, started good. And let's see, he should move up because he's currently moving right. So he tries to go up first. But before he does that, he's going to do this. Ooh, that worked. Let's see if he can move to the right. And yeah, that looked all right. That was funny. Let's see what was wrong. The reason why the enemy went all crazy is the section right here, which is if we're moving left, or in this case up, and then remove one, then we move the enemy from this position right here all the way up here, which is not what we want to do. We just want him to be positioned exactly in the coordinate like this. So we don't do minus anything if you're going up or if you're going left. So let's go back to the code and fix that real quick, which is simply to comment this section out, save, and now we can try it again. Maybe we should disable adding more enemies while doing this. So let's go to enemy, already playing, mouse clicked, and remove this, or comment this section out rather, by doing so. Now, let's just try with one enemy. This turn right here worked before, so should be no difference now either. That turn worked. Let's see if this one works too. And it does. So we fixed that, but it's gonna come another error here. Boom. So let's solve this next issue. And we have an index out of bounds. And this shouldn't be too much of an issue, because we got an index out of bounds error, which means we are trying to access an index in the array that doesn't exist. And we given a hint here, 20 out of 20. And if you look where it is, we're trying to access an index of 20 in this array, but that doesn't exist. So we can go back to EnemyManager and look how the code goes. We're trying to get the tile type right here. Then we go to playing, get the tile type, still using positions, but here we're using coordinates. So we're gonna do some checks in here to make sure that we're not checking less than 0 or more than 19, because our array is only 20 by 20, which is 0 to 19 in both directions. So we need to check that. And the easiest way to do it is just to create an integer, x chord equals x divided by 32. Now we have a x coordinate, and we also need an int coordinate. Int y chord equals y divided by 32. And then we just check if x coordinate is less than 0 or x coordinate is more than 19, then we return 0. And we're returning 0, which is a water tile, and you cannot walk on a water tile, so that is the same as returning false. You cannot walk here. And that's how we're going to solve it right here. But if the x coordinate succeeds, it's within bounds, then we check if y coord is less than 0 or y coord is more than 19. So the same check there, we return 0. And if both of these checks succeeds, then we get an ID to get a tile type and return that one. So if we save now and run it, and to avoid the enemy going completely crazy when he reaches here, because if he cannot go right, then he tries to go up, fails, so he goes down. But that's a grass tile. So it's just going to add a little bit of help here. And tell him to go up, and maybe try like so. This way he doesn't fly around the screen. So save. Then we go menu, play, and let's see what happens. It worked. So no index out of bounds error, and he can continue moving. Let's see what he does when he gets to this three-way crossing. And now he's gonna loop. So yeah, it worked. Now the enemy can check all tiles, and if the tiles is outside the bounds, then he just returns 0. Alright, I think this is a good stopping point. We got an enemy with pathfinding. A basic one, but it's working. In the next episode, we will improve this type of pathfinding. This would get very expensive because we check every update for every enemy, and I might have a solution for that. But that's for the next episode. Before you leave, I want to say thank you for watching, and I hope you learned something. If you did, smash the like button and also subscribe so you don't miss out on any coming updates. But until then, take care and have a great day. And I hope to see you in the next episode. Bye.